In this video, we're going to have a look at reviewing how to choose a statistical test. And in this case, I'm going to look at it with respect to the table 1, even though I'm not sure I would actually put any statistical tests on this table, just because you might need to for yours. And if you're not sure whether or not you need any p-values on this table, then watch my previous video on whether or not you need them. And just remember that whatever you choose to do, you still need to describe what's going on. And if you do find any significant differences, you need to interpret that for your reader. So I'm going to look at how we might go through choosing tests here. I'm assuming that you have done a first course in statistics and you are familiar with running each of these tests, and you just want to revise how to go about choosing an appropriate test. Now, if I was going to add on some tests to this table, rather than put it at the end, because I've got this overall column, and you won't always see an overall column in every table. Sometimes just the groups are presented. Sometimes you don't have any groups, you just have an overall column, and then you really don't need any testing. But in this case, if I was going to add some tests on, I would probably do it here, just because the tests would refer to the first 3 columns, not the overall column. So I'm just going to put significance there. Now, in terms of choosing a statistical test, you may have a flowchart from the course that you've completed. You can also Google statistical test flowchart, and you will come up with a lot of variations, and you can pick one that works for you. I have my own that I've developed that over the years, just to include the tests which are usually covered in maybe a first and second course in applied statistics. This does not contain every statistical technique ever created. I don't think it's even possible to fit all of statistics on a single flowchart if that's what you're looking for, because there's just too much. It's like saying, let's fit all of biology on a single flowchart. It's very complicated. It's not possible. So these are the things you're most likely to use in in an introductory capacity. And honestly, these techniques are used for a lot of health research anyway, so they're pretty, include some pretty useful techniques. The most important thing is to work out what your outcome variable is that you're testing. So let me bring up the table again. Now, where this can get confusing is that your outcome variable on your demographic table or your participant table is each of these variables here. It's not the main outcome for the study. When we get on to actually looking at what's our main thing that we want to find out, there we have a very specific outcome, and that is the main dependent variable that we're interested in. But in this case, where we're just trying to check, perhaps if we've got an experiment, is our design fair? Are there any major differences we need to be aware of when interpreting the results? That sort of thing. Each of these would count as your outcome or response variable, and these are the groups we're comparing. So let's have a look at the flow chart. So I would start at the top and work out, is your outcome continuous or scale, or is it nominal? Either of those cases, it's usually straightforward. If you have data which is ordinal, this is where it can get a little bit confusing, because there are actually a variety of things that you can do. So ordinal means ordered categories. If you have ordered categories that are not numeric, so if we have small, medium, and large, for example, we're pretty much going to treat that as nominal data and do probably a chi-squared test. Now, I haven't put all the variations of chi-squared tests in here. I think that's probably a bigger conversation because there are a few varieties, but just your standard Pearson chi-squared test is going to work in a lot of cases. You may want to do a test for trend. I don't think it's necessary really to do a continuity correction, but there you go. You can read up on these. If you have ordinal data which is numeric, there's actually a few things that you can do. Occasionally, you'll see that this data actually still gets treated as being categories, and people will still do chi-squared tests on it. It might depend a little bit what it looks like. It might get treated using non-parametric tests, and you'll also see it used with parametric techniques, especially where you've got these ratings on a scale, and the scales might go from 1 to 5, 1 to 10, It might be a larger scale like Beck's depression inventory or a perceived stress scale, something like that, really common for then that to be treated as continuous. If the data is approximately normal, and it doesn't need to be exactly normal, it's okay if there's problems with it. You can do some extra reading on the central limit theorem if you want, but it's really not necessary for your data to be normal to do a t-test. If there's something that's really unusual about the data, such as very heavy skew, lots of outliers, perhaps it looks bimodal, one of those situations means that perhaps the mean is not the best measure of the centre of the distribution, and that's why you might then use a non-parametric test. But just not being perfectly normal in itself is actually not a problem. So you're most likely going to be looking at either you've got a continuous outcome or you've got some kind of categorical outcome which might include ordinal. So it's really common on these table 1 of participant characteristics that you just see t-tests and chi-squared tests. There will be some situations where you see the non-parametric versions, Mann, Whitney, Yu. And if you've only got 2 groups, these are the ones you're going to see. If you've got paired data, I think it'll be very obvious from the start, and this is probably a little bit more unusual. So I don't think you're going to see a lot of these in the health literature. If you've got more than 2 groups, and that's when we just use sort of the next version up that can cope with a little bit more complexity, the ANOVA, Kruskal-Wallis, and again, the chi-squared test, that doesn't really change. So for us, in this example, we have 3 passenger classes that we're interested in. So we're going to be using ANOVA because we've got more than 2 groups for something that's continuous. If there's big problems with the data and it's really not normal, or it's got heavy skew, a lot of outliers, something else going on, then we might want to use the Kruskal-Wallis test, or what we would call the non-parametric version, which is a little bit inaccurate because it is actually testing something different. It's not a different way to test the means. It's not testing the means at all. But we might use a non-parametric test, and then we would still use the chi-squared test here. So these are the ones that you're going to be using for your table 1, most likely. When it comes to choosing a method for your primary outcome of interest, that's where we might move on to some of these other techniques. So I might talk about that in a separate video when we get up to it. But for now, let's go back to deciding about our tests that we're going to use in this example. How do I close this? There we go. F11 works every time. So something that might be helpful, if you've got some spare space on your table, you could actually write your test in. You could add in a little sort of footnote below the table. That's quite a neat way of doing it. It will usually go into your methods in your intended data analysis. You can write in which tests you're using, and you'll see a variety of things get done in the literature. So if you're curious, then go and read some papers and see how they've done it. I think it's helpful if you add a footnote explaining which tests you've done here, but just for ease of writing, I think I might put them up the top here. Now, here we've got a nominal outcome and 3 groups, so we would be using a chi-squared test. And we can actually see that there is a trend here already. So you probably would use the linear by linear association or the test for trend. If you have 3 categories, but there's no reason for you to suspect there would be a trend, or it's not going to be a linear trend, it goes up and then down or something like that, you can just use the Pearson chi-squared test if you want to test for differences between groups. And so perhaps I might use a test for trend here, but then I might just use the Pearson chi-squared test for age, because we've got this put into categories, but I'm not quite sure that I'm expecting any particular trend as over the age groups, because I have a feeling that each age group is just different. So I'm just going to put in chi-squared test again here. Now, Fair is an interesting one. I decided to summarise this with median and the interquartile range because there was some absolutely enormous fares. There were a lot of outliers and it was really heavily skewed. So if it made sense to summarise this with the medians, then I would use a non-parametric test, which would be the Kruskal-Wallis, because I've got the 3 groups. Can't remember if Kruskal has got 2 L's or 1. Can fix that up later. If you had summarised this with the mean and the standard deviation, then I would use an analysis of variance because I've got the 3 groups. But the test that you choose should match how you decided to summarise it. So this video is at 10 minutes. I'm not going to revise how to do each of these tests here. I might do that in a separate video if you would like to see more details, but I'm assuming that you've gone through that process of learning how to run these tests in SPSS, and this is about bringing it all together and making sure you can do it all for your project. So this is where you can make a decision about how you want to lay it out. Now this is looking a little bit cluttered already, so I'm just trying to think what footnotes you use are up to you. So I'm just going to use an A and I'll turn that into a superscript. Turn that off and then I'll put this information there. And then this font, just in terms of layout, I'd probably make this a smaller font. If you were actually submitting this to a journal, then you would need to follow the journal instructions. But if you're writing your own report and formatting how you see fit for your own report, then you can choose how to do this. I'm not sure I actually like the A anymore. Perhaps I would use some symbols. I'm not sure. Usually you would use the lowercase Latin letters to illustrate differences between the groups. So where you've got 3 groups, it might be that one group is significantly different to the other 2. And so you might use those lowercase letters to demonstrate the multiple comparisons tests. So perhaps I would change this. I might do that and then show you in the next video. So you can go through and I do recommend that you work out which tests you want to do and get your table set up, because then it makes it much easier to put in the numbers afterwards. So I might get that sorted out before the next video, and then we'll come back and talk about how to choose a test for our main analysis that we want to do.